Panther is the common name of a medium tank deployed by Nazi Germany in World War II from mid-1943 to the end of the European War in 1945. It was intended as a counter to the Soviet T-34, and as a replacement for the Panzer III and Panzer IV. While never replacing the latter, it served alongside it and the heavier Tiger tanks until the end of the war. The Panther's excellent combination of firepower, mobility, and protection served as a benchmark for other nations' late war and post-war tank designs, and it is regarded as one of the best tanks of World War II. Until 1944, it was designated as the Panzerkampfwagen V Panther and had the ordnance inventory designation of Sd.Kfz. 171. On February 27, 1944, Hitler ordered that the Roman numeral V be deleted from the designation. The Panther tank was a compromise of various requirements. While having essentially the same engine as the Tiger I tank, it had better frontal armor, better gun penetration, was lighter and thus faster, and could traverse rough terrain better than the Tigers. The trade-off was weaker side armor. The Panther proved to be deadly in open country and long-range engagements, but vulnerable in close-quarters combat. Also, the 75-on gun fired a slightly smaller shell than the Tiger's 88-on gun, providing less high-explosive firepower against infantry. The Panther was also far cheaper to produce than the Tiger tanks, and only slightly more expensive than the Panzer IV, as its design came to fruition when the Reich Ministry of Armament and War Production was making great efforts to increase war production. Key elements of the Panther design, such as its armor, transmission, and final drive, were compromises made specifically to improve production rates and address Germany's war shortages, whereas other over-engineered elements such as its highly compact engine and its complex suspension system remained. The result was that Panther tank production was far higher than what was possible for the Tiger tanks, but not much higher than what had been accomplished with the Panzer IV. At the same time, the simplified final drive became the single major cause of breakdowns of the Panther tank, and was a problem that was never corrected. The Panther tank arrived in 1943 at a crucial phase in World War II for Germany. Rushed into combat at the Battle of Kursk with uncorrected teething problems, which resulted in breakdowns and other equipment failures, the Panther tank would thereafter only be fighting outnumbered in Germany's steady retreat against the Allies for the remainder of World War II. Its success as a battlefield weapon was thus hampered by Germany's generally declining position in the war, with the loss of air power protection by the Luftwaffe, the loss of fuel and training space, and the declining quality of tank crews. Nevertheless, the Panther tank commanded respect from the Allies, and its combat capabilities led directly to the introduction of heavier Allied tanks such as the Soviet Is-2 and the American M-26 Pershing into the war and the development of the formidable British Centurion tank, even though it appeared too late to participate in World War II. Development and production, design. The Panther was a direct response to the Soviet T-34 and KV-1 tanks. First encountered on June 23, 1941, the T-34 outclassed the existing models of the Panzer III and IV. At the insistence of General Heinz Guderian, a special Panzer commission was dispatched to the Eastern Front to assess the T-34. Among the features of the Soviet tank considered most significant were the sloping armor, which gave much improved shot deflection and also increased the effective armor thickness against penetration, the wide track, which improved mobility over soft ground, and the 76.2-ohm gun, which had good armor penetration and fired an effective high-explosive round. Daimler-Benz and Maschinenfabrik Augsburg Nah 1/4 RNBERGAG were given the task of designing a new 30 to 35-ton tank, designated VK30.02, by April 1942. The DB design resembled the T-34 in hull and turret form. DB's proposal used a leaf spring suspension, in contrast to the T-34's coil spring suspension. The leaf spring suspension lay outside of the hull. Subsequently, the hull was more narrow, offering a smaller turret ring. Thus, the DB turret was necessarily smaller than that of the MAN design. The main advantages of the leaf springs over a torsion bar suspension were lower hull silhouette and a simpler shock damping design. Like the T-34, The DB design had a rear drive sprocket and a forward-situated turret, but unlike the T-34, the DB design had the preferred three-man turret crew, commander, gunner, and loader. As the planned L/70-75 mm gun was much larger than the T-34's, mounting it in the Daimler-Benz turret was difficult. Plans to address the space limitations by reducing the turret crew to 2 men were considered, but were eventually discarded as experience had shown this to be a less effective arrangement. The MAN design embodied more conventional German thinking with the transmission and drive sprocket in the front and a centrally mounted turret. It had a gasoline engine and 8 torsion bar suspension axles per side. Because of the torsion bar suspension and the drive shaft running under the turret basket, the MAN Panther was higher and had a wider hull than the DB design. The Henschel firm's design concepts for their Tiger I tank's suspension drive components, using its characteristic Scotch-to-Laufwerk format large, overlapping, interleaved road wheels with a slack track using no return rollers for the upper run of track were repeated with the MAN design for the Panther. These large, rubber-rimmed steel wheels added to the protection of the hull from a lateral penetrating shot. The two designs were reviewed over a period from January through March 1942. Reich Minister Todt, and later, his replacement Albert Speer, both recommended the DB design to Hitler because of his several advantages over the initial MAN design. However, at the final submission, MAN improved their design, having learned from the DB proposal, and a review by a special commission appointed by Hitler in May 1942 ended up selecting the MAN design. Hitler approved this decision after reviewing it overnight. One of the principal reasons given for this decision was that the MAN design used an existing turret designed by Rheinmetall Borsig, while the DB design would have required a brand new turret to be designed and produced, substantially delaying the commencement of production. Albert Speer recounts in his autobiography Inside the Third Reich. Since the Tiger had originally been designed to weigh 50 tons but as a result of Hitler's demands had gone up to 75 tons, we decided to develop a new 30-ton tank whose very name, Panther, was to signify greater agility. Though light in weight, its motor was to be the same as the Tiger's, which meant it could develop superior speed. But in the course of a year Hitler once again insisted on clapping so much armor on it, as well as larger guns, that it ultimately reached 48 tons, the original weight of the Tiger. Production: the MAN design also had better fording ability, easier gun servicing and higher mobility due to better suspension, wider tracks, and a bigger fuel tank. A mild steel prototype was produced by September 1942 and, after testing at Kummersdorf, was officially accepted. It was put into immediate production. The start of production was delayed, however, mainly because there were too few specialized machine tools needed for the machining of the hull. Finished tanks were produced in December and suffered from reliability problems as a result of this haste. The demand for this tank was so high that the manufacturing was soon expanded beyond MAN to include Daimler-Benz, Maschinenfabrik Niedersachsen Hanover and Henschel and Sohn in Kassel. The initial production target was 250 tanks per month at MAN plant Nuremberg. This was increased to 600 per month in January 1943. Despite determined efforts, this figure was never reached due to disruption by Allied bombing, manufacturing bottlenecks, and other difficulties. Production in 1943 averaged 148 per month. In 1944, it averaged 315 a month, peaking with 380 in July and ending around the end of March 1945, with at least 6,000 built in total. Frontline combat strength peaked on September 1, 1944 at 2,304 tanks, but that same month a record number of 692 tanks were reported lost. Allied bombing was first directed at the common choke point for both Panther and Tiger production, the Maybach engine plant. This was bombed the night of 27/April 28, 1944 and production was shut down for 5 months. A second manufacturer factory had already been planned, the Auto Union Sigma plant, and this came online in May 1944. Targeting of Panther factories began with a bombing raid on the DB plant on August 6, 1944, and again on the night of 23/August 24. MAN was struck on September 10, October 3 and October 19, 1944, and then again on January 3 and 20/February 21, 1945. MNH was not attacked until 14 and 28 March 1945. In addition to interfering with tank production goals, the bombing forced a steep drop in the production of spare parts. Spare parts as a percentage of tank production dropped from 25–30% in 1943, to 8% in the fall of 1944. This only compounded the problems with reliability and the numbers of operational Panthers, as tanks in the field had to be cannibalized for parts. Production figures. The Panther was the third most produced German armored fighting vehicle, after the Sturmgeschütz 1/4 TZ3 assault gun tank destroyer at 9,408 units, and the Panzer IV tank at 8,298 units. Cost. One source has cited the cost of a Panther tank as 117,100 Reichsmarks. This compared with 82,500 RM for the Sturmgeschütz, 96,163 RM for the Panzer III, 103,462 RM for the Panzer IV, and 250,800 RM for the Tiger I. These figures did not include the cost of the armament and radio. In terms of Reichsmarks per ton, therefore, the Panther tank was one of the most cost-effective of the German armored fighting vehicles of World War II. Using conscript labor on the production lines greatly reduced costs but also greatly reduced reliability. French Army studies in 1947 found that many Panthers had been sabotaged in production. However, these cost figures should be understood in the context of the time period in which the various armored fighting vehicles were first designed, as the Germans increasingly strove for designs and production methods that would allow for higher production rates, and thus steadily reduced the cost of their armored fighting vehicles. For example, another source has cited the total cost of the early production Tiger I in 1942 euro 1943 to be as high as 800,000 RM. The process of streamlining the production of German armored fighting vehicles first began after Speer became Reichsminister in early 1942, and steadily accelerated through 1944. Production of the Panther tank thus coincided with this period of increased manufacturing efficiency. At the beginning of the war, German armored fighting vehicle manufacturers had employed labor-intensive and costly manufacturing methods unsuitable for the needs of mass production. Even with streamlined production methods, Germany never approached the efficiency of Allied manufacturing during World War II. Design characteristics. The weight of the production model was increased to 45 metric tons from the original plans for a 35-ton tank. Hitler had personally reviewed the final designs and insisted on an increase in the thickness of the frontal armor. The front glacis plate was increased from 60 mm to 80 mm and the turret front plate was increased from 80 mm to 100 mm. The Panther was rushed into combat before all of its teething problems had been corrected. Reliability was considerably improved over time, and the Panther did prove to be a very effective fighting vehicle. However, some design flaws, such as its weak final drive units, were never corrected due to various shortages in German war production. The crew comprised 5 members: driver, radio operator, gunner, loader, and commander. Engine. The first 250 Panthers were powered by a Maybach Hill 210 P30 engine, V12 gasoline engine which delivered 650 metric HP at 3,000 RPMs and had 3 simple air filters. Starting in May 1943, the Panthers were built using the 700 picoseconds per 3,000 RPM, 23.1-liter Maybach Hill 230 P30 V12 gasoline engine. To save aluminum, the light alloy block used in the HL210 was replaced by a cast iron block. 2 multi-stage cyclone air filters were used to automate some of the dust removal process. In practice, due to the use of low-quality gasoline, the engine power output was reduced. With a capacity of 190 US gallons of fuel, a fully fueled Panther could travel 97 euro 130 km on roads and 64 euro 80 km cross-country. The Hill 230 P30 engine was a very compact design, which kept the space between the cylinder walls to a minimum. The crankshaft was composed of 7 discs, each with an outer race of roller bearings, and a crankshaft pin between each disc. To reduce the length of the engine further, by 1/2 a cylinder diameter, the 2 banks of 6 cylinders of the V12 were not offset. The big ends of the connecting rods of each cylinder pair in the V, where they mated with the crank pin, were thus at the same spot with respect to the engine block's length rather than offset. This required a fork and blade-matched pair of cone rods for each transversely oriented pair of cylinders. Usually, V-form engines have their transversely paired cylinders' cone rods big ends simply placed side by side on the crank pin, with their transverse pairs of cylinders offset to match. This compact arrangement with the connecting rods was the source of considerable teething problems early on. Blown head gaskets were another problem, which was corrected with improved seals in September 1943. Improved bearings were introduced in November 1943 to replace the faulty ones that had failed frequently. An engine governor was also added in November 1943 that reduced the maximum engine speed to 2,500 rpm. An 8th crankshaft bearing was added beginning in January 1944 to help reduce motor failures. The engine compartment space was designed to be watertight so that the Panther could be submerged and cross waterways. The result was that the engine compartment was poorly ventilated and prone to overheating. The fuel connectors in the early models were non-insulated, leading to leakage of fuel fumes into the engine compartment. This led to many engine fires in the early Panthers. Additional ventilation was added to draw off these gases, which mitigated but did not completely solve the problem of engine fires. Other measures taken to reduce this problem included improving the coolant circulation inside the motor and adding a reinforced membrane spring to the fuel pump. The Panther had a solid firewall separating the engine compartment and the fighting compartment to keep engine fires from spreading. The engine became more reliable over time. A French assessment of their stock of captured Normandy Panther A's in 1947 concluded that the engine had an average life of 1,000 km and maximum life of 1,500 km. Suspension. The suspension consisted of front drive sprockets, rear idlers and 8 double-interleaved rubber-rimmed steel road wheels on each side in the so-called Skarch-to-Laufwerk design, very similar to the Tiger Eye's own road wheel arrangement, pioneered for large-scale production German full-track armored fighting vehicles in 1942. Suspended on a dual torsion bar suspension. The dual torsion bar system, designed by Professor Ernst Lew, allowed for a wide travel stroke and rapid oscillations with high reliability, thus allowing for relatively high-speed travel by this heavy tank over undulating terrain. However, the extra space required for the bars running across the length of the bottom of the hull, below the turret basket, increased the overall height of the tank and also prevented any chance for a provision for an escape hatch in the hull bottom. When damaged by mines, the torsion bars often required a welding torch for removal. The Panther's suspension was complicated to manufacture and the Skarch-to-Laufwerk interleaved road wheel system made replacing inner road wheels time-consuming. The interleaved wheels also had a tendency to become clogged with mud, rocks and ice, and could freeze solid overnight in the harsh winter weather that followed the autumn Rasputitsa mud season of the Eastern Front. Shell damage could also cause the road wheels to jam together and become extremely difficult to separate. Interleaved wheels had long been standard on all German half-tracks. The extra wheels did provide better flotation and stability, and also provided more armor protection for the thin hull sides than smaller wheels or non-interleaved wheel systems, but the complexity meant that no other country ever adopted this design for their tanks. In September 1944, and again in March-April 1945, MAN built a limited number of Panther tanks with overlapping, non-interleaved steel-rimmed road wheels originally designed for the Tiger II and late series Tiger I tanks. Steel-rimmed road wheels were introduced from chassis number 121052 due to raw material constraints. From November 1944 through February 1945, a conversion process began to use sleeve bearings in the Panther tank, as there was a shortage of ball bearings. The sleeve bearings were primarily used in the running gear. Plans were also made to convert the transmission to sleeve bearings, but were not carried out as production of Panther tanks came to an end. Steering and transmission. Steering was accomplished through a 7-speed AK-7-200 Synchromesh gearbox, designed by Zahnradfabrik Friedrichshafen, and a MAN single-radius steering system, operated by steering levers. Each gear had a fixed radius of turning, ranging from 5 meters for first gear up to 80 meters for seventh gear. The driver was expected to judge the sharpness of a turn ahead of time and shift into the appropriate gear to turn the tank. The driver could also engage the brakes on one side to force a sharper turn. This manual steering was a much simplified design, compared to the more sophisticated dual-radius hydraulically controlled steering system of the Tiger tanks. The AK-7-200 transmission was also capable of pivot turns, but this method of turning could accelerate failures of the final drive. Throughout its career, the weakest parts were its final drive units. The problems were from a combination of factors. The original MAN proposal had called for the Panther to have an epicyclic gearing system in the final drive, similar to that used in the Tiger I. However, Germany at the time suffered from a shortage of gear-cutting machine tools and, unlike the Tiger tanks, the Panther was intended to be produced in large numbers. To achieve the goal of higher production rates, numerous simplifications were made to the design and its manufacture. This process was aggressively pushed forward, sometimes against the wishes of designers and army officers, by the Chief Director of Armament and War Production, Karl Otto Saar. Consequently, the final drive was changed to a double-spur system. Although much simpler to produce, the double-spur gears had inherently higher internal impact and stress loads, making them prone to failure under the high torque requirements of the heavy Panther tank. Furthermore, high-quality steel intended for double-spur system was not available for mass production, and was replaced by 37mm C5 tempered steel, which was unsuitable for high-stress gear. In contrast, both the Tiger II and the US M4 Sherman tank had double helical in their final drives, a system that reduced internal stress loads and was less complex than planetary guard trains. Compounding these problems was the fact that the final drive's housing and gear mountings were too weak because of the type of steel used and or the tight space allotted for the final drive. The final gear mountings deformed easily under the high torque and stress loads, pushing the gears out of alignment and resulting in failure. Due to the weakness of the final drives, their average fatigue life was only 150 km. In Normandy, about half of the abandoned Panthers were found by the French to have broken final drives. The final gear housing was eventually replaced with a stronger one, while the final gear problem was never solved. Plans were made to replace the final drive either with a version of the original epicyclic gears planned by MAN, or with the final drive of the Tiger II. These plans were intertwined with the planning for the Panther II, which never came to fruition because the Panzer Commission deemed that a temporary drop in production of the Panther due to a merger of Tiger II and Panther II would be unacceptable. It was estimated that building the epicyclic gear final drive would have required 2.2 times more machining work than double-spur gears, and this would have affected manufacturing output. Most of the shortcomings were considered acceptable once design flaws were rectified. Due to the mechanical unreliability of the final gear, the Panther had to be driven with care, a characteristic shared with the Tiger tanks as well as Jagdtigers. Long road marches would result in a significant number of losses due to breakdowns, and so the German army had to ship the tanks by rail as close to the battlefield as possible. Armor. Initial production Panthers had a face-hardened glacis plate, but as armor-piercing capped rounds became the standard in all armies, this requirement was deleted on March 30, 1943. By August 1943, Panthers were being built only with a homogeneous steel glacis plate. The front hull had 80 mm of armor angled at 55 degrees from the vertical, welded but also interlocked for strength. The combination of well-sloped and thick armor meant that few Allied or Soviet weapons could penetrate this part of the tank. The armor for the side hull and superstructure was much thinner. The thinner side armor was necessary to keep the overall weight within reasonable bounds, but it made the Panther vulnerable to attacks from the side by most Allied and Soviet tank and anti-tank guns. German tactical doctrine for the use of the Panther thus emphasized the importance of flank protection. 5 mm thick skirt armor, known as Sh-1/4 intended to provide protection for the lower side hull from Soviet anti-tank rifle fire, was fitted on the hull side. Zimerit coating against magnetic mines started to be applied at the factory on late AUSFD models beginning in September 1943. An order for field units to apply Zimerit to older versions of the Panther was issued in November 1943. In September 1944, orders to stop all application of Zimerit were issued, based on false rumors that hits on the Zimerit had caused vehicle fires. Panther crews were aware of the weak side armor and made unauthorized augmentations by hanging track links or spare road wheels onto the turret and or the hull sides. The rear hull top armor was only 16 mm thick, and had 2 radiator fans and 4 air intake louvers over the engine compartment that were vulnerable to strafing by aircraft. As the war progressed, Germany was forced to reduce or no longer use certain critical alloy materials in the production of armor plate, such as nickel, tungsten, molybdenum, and manganese. This resulted in lower impact resistance levels compared to earlier armor. Manganese from mines in the Ukraine became unavailable when the German army lost control of this territory in February 1944. Allied bombers struck the Nabe mine in Norway and stopped a key source of molybdenum. Other supplies from Finland and Japan were also cut off. The loss of molybdenum, and its replacement with other substitutes to maintain hardness, as well as a general loss of quality control, resulted in an increased brittleness in German armor plate, which developed a tendency to fracture when struck with a shell. Testing by U.S. Army officers in August 1944 in Nijmegen, France showed catastrophic cracking of the armor plate on 2 out of 3 Panthers examined. Armament. The main gun was a 7.5 cm Rheinmetall Borsig Kw-K42 with semi-automatic shell ejection and a supply of 79 rounds. The main gun used 3 different types of ammunition, APCBCE, HE and APCR, the last of which was usually in short supply. While it was of only average caliber for its time, the Panther's gun was one of the most powerful tank guns of World War II, due to the large propellant charge and the long barrel, which gave it a very high muzzle velocity and excellent armor-piercing qualities. The flat trajectory also made hitting targets much easier, since accuracy was less sensitive to range and increased the chance of hitting a moving target, though these same attributes made the gun a poor fire support weapon using HE ammo. The Panther's 75 ohm gun had more penetrating power than the main gun of the Tiger I heavy tank, the 8.8 cm KW-K36L/56, although the larger 88 ohm projectile might inflict more damage if it did penetrate. The tank typically had 2 MG-34 machine guns of a specific version designed for use in armored combat vehicles featuring an armored barrel sleeve. An milligram 34 machine gun was located coaxially with the main gun on the gun mantlet. An identical MG-34 was located on the glacis plate and fired by the radio operator. Initial AUSF D and early AUSF A models used a letterbox flap enclosing its underlying thin, vertical arrow slit-like aperture, through which the machine gun was fired. In later AUSF-A and all AUSF-G models, a ball mount in the glacis plate with a KZF-2 machine gun sight was installed for the hull machine gun. Turret. The front of the turret was a curved 100 ohm thick cast armor mantlet. Its transverse cylindrical shape meant that it was more likely to deflect shells, but the lower section created a shot trap. If a non-penetrating hit bounced downwards off its lower section, it could penetrate the thin forward hull roof armor, and plunge down into the front hull compartment. Penetrations of this nature could have catastrophic results, since the compartment housed the driver and radio operator sitting along both sides of the massive gearbox and steering unit. Even worse, 4 magazines containing main gun ammunition were located between the driver radio operator seats and the turret, directly underneath the gun mantlet when the turret was facing forward. From September 1944, a slightly redesigned mantlet with a flattened and much thicker lower chin design started to be fitted to Panther AUSF-G models, the chin being intended to prevent such deflections. Conversion to the chin design was gradual, and Panthers continued to be produced to the end of the war with a rounded gun mantlet. In most cases the Panther's gun mantlet could not be penetrated by the M4's 75 mm gun, the T-34's 76.2 mm gun, or the T-34-85 85 mm gun. But it could be penetrated by well-aimed shots at 100 am by the 76 mm M1A1 gun used on certain models of the M4, at 500 am by the Soviet A19 122 mm gun on the IS-2, and at 2300 am by the British Ordnance QF 17-pounder using APDS ammunition. The side turret armor of 45 mm was vulnerable to penetration at long range by almost all Allied tank guns, including the M4's 75 mm gun, which could penetrate it at 1500 am. These were the main reasons for continued work on a redesigned Panther turret, the Schmalturm. The AUSFA model introduced a new cast armor commander's cupola, replacing the more difficult-to-manufacture forged cupola. It featured a steel hoop to which a third MG-34 or either the coaxial or the bow machine gun could be mounted for use in the anti-aircraft role, though it was rare for this to be used in actual combat situations. The first Panthers had a hydraulic motor that could traverse the turret at a maximum rate of 1 complete revolution in 1 minute, independent of engine speed. This slow speed was improved in the AUSFA model with a hydraulic traverse that varied with engine speed. One full turn taking 46 seconds at an engine speed of 1000 rpms, but only 15 seconds if the engine was running at 3000 rpms. This arrangement was a slight weakness, as traversing the Panther's turret rapidly onto a target required close coordination between the gunner and driver, who had to run the engine to maximum speed. By comparison, the turret of the M4 Sherman turret traversed at up to 360 degrees in 15 seconds and was independent of engine speed, which gave it an advantage over the Panther in close quarters combat. As usual for tanks of the period, a hand traverse wheel was provided for the Panther gunner to make fine adjustment of his aim. Ammunition storage. Ammunition storage for the main gun was a weak point. All the ammunition for the main armament was stored in the hull, with a significant amount stored in the sponsons. In the AUSFD and A models, 18 rounds were stored next to the turret on each side, for a total of 36 rounds. In the AUSFG, which had deeper sponsons, 24 rounds were stored on each side of the turret, for a total of 48 rounds. In all models, 4 rounds were also stored in the left sponson between the driver and the turret. An additional 36 rounds were stored inside the hull of the AUSFD and A models, 27 in the forward hull compartment directly underneath the mantlet. In the AUSFG, the hull ammunition storage was reduced to 27 rounds total, with 18 rounds in the forward hull compartment. For all models, 3 rounds were kept under the turntable of the turret. The thin side armor could be penetrated at combat ranges by many Allied tank guns, and this meant that the Panther was vulnerable to catastrophic ammunition fires if hit from the sides. The loader was stationed in the right side of the turret. With the turret facing forward, he had access only to the right sponson and hull ammunition, and so these served as the main ready ammunition bins. Combat use. Panthers were supplied to form Panzer 80 along 51 on January 9, and then PZ-ABD 52 on February 6, 1943. The first production Panther tanks were plagued with mechanical problems. The engine was dangerously prone to overheating and suffered from connecting rod or bearing failures. Gasoline leaks from the fuel pump or carburetor, as well as motor oil leaks from gaskets, easily produced fires in the engine compartment. Several were destroyed in such fires. Transmission and final drive breakdowns were the most common and difficult to repair. A large list of other problems were detected in these early Panthers, and so from April through May 1943 all Panthers were shipped to Falkensee and Wannenberg for a major rebuilding program. This did not correct all of the problems, so a second program was started at Grafenwöhr and Erlangen in June 1943. Eastern Front. The Panther tank was seen as a necessary component of the upcoming Operation Zitadel, and the attack was delayed several times because of their mechanical problems, with the eventual start date of the battle only 6 days after the last Panthers had been delivered to the front. This resulted in major problems in Panther units during the Battle of Kursk, as tactical training at the unit level, coordination by radio, and driver training were all seriously deficient. It was not until June 29, 1943 that a total of 200 rebuilt Panthers were finally issued to Panther Regiment von Lauchert, of the XLVII Panzer Corps. 2 were immediately lost due to motor fires upon disembarking from the trains. By July 5, when the Battle of Kursk started, there were only 184 operational Panthers. Within 2 days, this had dropped to 40. On July 17, 1943, after Hitler had ordered a stop to the German offensive, General Heinz Guderian sent in the following preliminary assessment of the Panthers. Due to enemy action and mechanical breakdowns, the combat strength sank rapidly during the first few days. By the evening of July 10 there were only 10 operational Panthers in the front line. 25 Panthers had been lost as total write-offs. 100 Panthers were in need of repair. 60% of the mechanical breakdowns could be easily repaired. Approximately 40 Panthers had already been repaired and were on the way to the front. About 25 still had not been recovered by the repair service. On the evening of July 11, 38 Panthers were operational, 31 were total write-offs and 131 were in need of repair. A slow increase in the combat strength is observable. The large number of losses by hits attests to the heavy fighting. During Zeitadel the Panthers claimed 267 destroyed tanks. A later report on July 20, 1943 showed 41 Panthers as operational, 85 as repairable, 16 severely damaged and needing repair in Germany, 56 burnt out, and 2 that had been destroyed by motor fires. However, before the Germans ended their offensive at Kursk, the Soviets began their counter-offensive, and succeeded in pushing the Germans back into a steady retreat. Thus, a report on August 11, 1943 showed that the numbers of total write-offs in Panthers swelled to 156, with only 9 operational. The German army was forced into a fighting retreat and increasingly lost Panthers in combat as well as from abandoning and destroying damaged vehicles. The Panther demonstrated its capacity to destroy any Soviet AFV from long distance during the Battle of Kursk, and had a very high overall kill ratio. However, it comprised less than 7% of the estimated 2,400 to 2,700 total AFVs deployed by the Germans in this battle, and its effectiveness was limited by its mechanical problems and the in-depth lead defense system of the Soviets at Kursk. Its greatest historical role in the battle may have been a highly negative its contribution to the decisions to delay the original start of Operation Zeitadel for a total of 2 months, time which the Soviets used to build up an enormous concentration of minefields, anti-tank guns, trenches and artillery defenses. After the losses of the Battle of Kursk, the German army went into a permanent state of retreat against the Red Army. The numbers of Panthers were slowly rebuilt on the Eastern Front, and the operational percentage increased as its reliability was improved. In March 1944, Guderian reported, "Almost all the bugs have been worked out, although many units continued to report significant mechanical problems, especially with the final drive." The greatly outnumbered Panthers came to be used as mobile reserves to fight off major attacks. The highest total number of operational Panthers on the Eastern Front was achieved in September 1944, when some 522 were listed as operational out of a total of 728. Throughout the rest of the war, Germany continued to keep the great majority of Panther forces on the Eastern Front, where the situation progressively worsened for the Germans. The last recorded status, on March 15, 1945, listed 740 on the Eastern Front with 361 operational. By this time the Red Army had entered East Prussia and was advancing through Poland. In August 1944, Panthers were deployed in Warsaw during the uprising as mobile artillery and troop support. At least 2 of them were captured in the early days of the conflict and used in actions against Germans, including the liberation of GAR and registered trademark IR-WKA concentration camp on August 5, when the soldiers of Wake Platoon used the captured Panther to destroy the bunkers and watchtowers of the camp. Most of the Germans in the camp were killed. The insurgents had lost 2 people and liberated almost 350 people. After several days they were immobilized due to the lack of fuel and batteries and were set ablaze to prevent them from being recaptured by the German forces. Western Front, France. At the time of the invasion of Normandy, there were initially only 2 Panther-equipped Panzer regiments in the Western Front, with a total of 156 Panthers between them. From June through August 1944, an additional 7 Panther regiments were sent into France, reaching a maximum strength of 432 in a status report dated July 30, 1944. The majority of German panzer forces in Normandy, Euro 6.5 divisions, were drawn into the fighting around the town of Caen. Here, they checked the Anglo-Canadian forces of the 21st Army Group. The numerous battles to secure the town became collectively known as the Battle of Caen. While there were sectors of heavy bocage around Caen, there were also many open fields which allowed the Panther to engage the attacking enemy armour at long range. Conversely, by the time of the Normandy campaign, British divisional anti-tank regiments were well equipped with the excellent 17-pounder gun, making it equally as perilous for Panthers to attack across these same fields. The British had begun converting regular M4 Shermans to carry the 17-pounder gun prior to the D-Day landings, and while limited numbers meant that during Normandy not more than 1 Sherman in 4 were of the Firefly variant, the lethality of its gun against German armour made them priority targets for German gunners. U.S. forces in the meantime, facing 1.5 German panzer divisions, mainly the Panzer Lu division, struggled in the heavy, low-lying bocage terrain west of Caen. Against the M4 Shermans of the Allied tank forces during this time, the Panther tank proved to be most effective when fighting in open country and shooting at long range. Its combination of superior armor and firepower allowed it to engage at distances from which the Shermans could not respond. However, the Panther struggled in the bocage country of Normandy, and was vulnerable to side and close-in attacks in the built-up areas of cities and small towns. The commander of the Panzer Lu division, General Fritz Berlin, reported on the difficulties experienced by the Panther tank in the fighting in Normandy. While the PZK-PFW-4 could still be used to advantage, the PZK-PFW V Panther proved ill-adapted to the terrain. The Sherman, because of its maneuverability and height, was good. The Panther was poorly suited for hedgerow terrain because of its width. Long gun barrel and width of tank reduce maneuverability in village and forest fighting. It is very front-heavy and therefore quickly wears out the front final drives, made of low-grade steel. High silhouette. Very sensitive powertrain requiring well-trained drivers. Weak side armor. Tank top vulnerable to fighter bombers. Fuel lines of porous material that allow gasoline fumes to escape into the tank interior, causing a grave fire hazard. Absence of vision slits makes defense against close attack impossible. Through September and October, a series of new Panzer brigades equipped with Panther tanks were sent into France to try to stop the Allied advance with counterattacks. This culminated in the Battle of Arroquet, in which the mostly Panther-equipped German forces suffered heavy losses fighting against the 4th Armoured Division of Patton's Third Army, which was still primarily equipped with 75 M4 Sherman tanks and yet came away from the battle with only a few losses. The Panther units were newly formed, poorly trained, and tactically disorganized. Most units ended up stumbling into ambush situations against seasoned U.S. tank crews. Western Front, Ardennes Offensive. A status report on December 15, 1944 listed an all-time high of 471 Panthers assigned to the Western Front, with 336 operational. This was one day before the start of the Battle of the Bulge. 400 of the tanks assigned to the Western Front were in units sent into the offensive. The Panther once again demonstrated its prowess in open country, where it could shoot its victims at long range with near impunity, and its vulnerability in the close-in fighting of the small towns of the Ardennes, where they suffered heavy losses. A status report on January 15, 1945 showed only 97 operational Panthers left in the units involved in the operation, out of 282 still in their possession. Total write-offs were listed as 198. The Operation Grief Commando mission included 5 Panthers assigned to Panzer Brigade 150, disguised to look like M10 tank destroyers by welding on additional plates, applying US-style camouflage paint and markings. This was carried out as part of a larger operation that involved soldiers disguised as Americans and other activities. The disguised Panthers were detected and destroyed. In February 1945, 8 Panzer divisions with a total of 271 Panthers were transferred from the west to the Eastern Front. Only 5 Panther battalions remained in the west. One of the top German Panther commanders was SS Oberstscharfe 1 Quarter Ernst Bachmann of the 2nd SS Panzer Regiment Das Reich. By the end of the war, he had some 80 tank kills claimed. Fortification. From 1943, Panther turrets were mounted in fixed fortifications. Some were normal production models, but most were made specifically for the task, with additional roof armor to withstand artillery. 2 types of turret emplacements were used. And they housed ammunition storage and fighting compartment along with crew quarters. A total of 182 of these were installed in the fortifications of the Atlantic Wall and West Wall, 48 in the Gothic Line and Hitler Line, 36 on the Eastern Front, and 2 for training and experimentation, for a total of 268 installations by March 1945. They proved to be costly to attack, and difficult to destroy. Battalion organization. From September 1943, 1 Panzer battalion with 96 Panthers comprised the Panzer Regiment of the Panzer Division 43. Battalion Command. Communication Platoon, 3 Befehlswagen Panther Sd.Kfz 267/268, Reconnaissance Platoon, 5 Panther, 1st Company, 22 Panther, Company Command, 2 Panther, 1st Platoon, 5 Panther, 2nd Platoon, 5 Panther, 3rd Platoon, 5 Panther, 4th Platoon, 5 Panther. 2nd Company, 22 Panther, 3rd Company, 22 Panther, 4th Company, 22 Panther, Service Platoon, 2 BG Panther Sd.Kfz 179. From August 3, 1944, the new Panzer Division 44 organization called for a Panzer Division to consist of 1 Panzer Regiment with 2 Panzer battalions, one of 96 Panzer IVs and 1 of 96 Panthers. Actual strengths tended to differ, and became far lower after losses. The Allied response, Soviet, the appearance of the Panther on the Eastern Front led to another step in the ongoing arms race between the Germans and Soviets to produce AFVs with ever greater armor and firepower. The Tiger I and Panther tanks were German responses to encountering the T-34 in 1941. Soviet firing tests against a captured Tiger in April 1943 showed that the T-34's 76 mm gun could not penetrate the front of the Tiger I at all, and the side only at very close range. An existing Soviet 85 mm anti-aircraft gun, the 52K, was found to be very effective against the frontal armor of the Tiger I, and so a derivative of the 52K 85 mm gun was developed for the T-34. The Soviets thus had already embarked on the 85 mm gun upgrade path before encountering the Panther tank at the Battle of Kursk. After much development work, the first T-34-85 tanks entered combat in March 1944. The production version of the T-34's new 85 mm gun proved to be ineffective against the Panther's frontal armor, meaning the Soviet tank had to flank the Panther to destroy it, while the Panther's main gun could penetrate the T-34 at long range from any angle. Although the T-34-85 tank was not quite the equal of the Panther, it was much better than the 76.2 mm armed versions and made up for its quality shortcomings by being produced in greater quantities than the Panther. New self-propelled anti-tank vehicles based on the T-34 hull, such as the Su-85 and Su-100, were also developed. A German army study dated October 5, 1944 showed that the Panther could easily penetrate the turret of the T-34-85 from the front at ranges up to 2,000 am, and the frontal hull armor at 3,000 am, whereas from the front, the T-34-85 could only penetrate the non-mantlet part of the Panther turret at 500 am. From the side, the two were nearly equivalent as both tanks could penetrate the other from long range. The Battle of Kursk convinced the Soviets of the need for even greater firepower. A Soviet analysis of the battle in August 1943 showed that a core artillery piece, the A-19 122mm gun, had done well against the German AFVs in that battle, and so development work on the 122mm equipped IS-2 began in late 1943. First encounters with hostile enemy tanks revealed that the 122mm BR-471 armor-piercing shell could only punch through the Panther's frontal armor at a range of 600–700 meters. The early results of the IS-2's combat employment, which were confirmed by firing tests in Treblinka 1944, compelled the designers to seek innovative solutions. German testing at Kummersdorf showed that the 122mm gun could not penetrate the glacis plate of the Panther at all at 30 degrees, could penetrate the nose at 100 m and the turret mantlet of the Panther at ranges up to 600 m. The Panther's 75mm gun could penetrate the front of the IS-2's turret at over 1000 am, the driver's front plate at 1000 am and the hull nose at 1000 am. From the side, the Panther was more vulnerable than the IS-2. Thus the two tanks, while nearly identical in weight, had quite different combat strengths and weaknesses. The Panther carried much more ammunition and had a faster firing cycle than the IS-2, which was a lower and more compact design. The IS-2's D-25T 122mm gun used a two-piece ammunition which slowed its firing cycle to 1.5–2 rounds per minute on average. American and British. The response of the Western Allies to the Panther was confused. The Western Allies were aware of the Panther and had access to technical details through the Soviets, but there was a difference in the American and British camps as to the significance of the tank. After taking 2 years to catch up with German tank design in Africa, the British were wary of falling behind yet again. They had developed the excellent 17-pounder anti-tank gun, but had no vehicle that could fit this large gun into its turret. For its part, the U.S. Army did not believe the Panther would be a significant problem, and did not foresee their armored forces having to fight pitched engagements against the Panther. The Panther was not seen in combat by the Western Allies until early 1944 at Enzio in Italy, where Panthers were employed in small numbers. Until just before D-Day, the Panther was thought to be another heavy tank that would not be built in large numbers. Shortly before D-Day, Allied intelligence reported that large numbers of Panthers were being used in the Panzer divisions, and an attempt was made to investigate Panther production. Using a statistical analysis of the serial numbers on the road wheels on two captured tanks, U.S. intelligence estimated Panther production for February 1944 to be 270 units, much greater than what had been anticipated. This indicated the Panther would be encountered in much larger numbers than had previously been thought. In the planning for the Battle of Normandy, the U.S. Army expected to face a handful of German heavy tanks alongside large numbers of Panzer IVs. At this point it was too late to prepare to face the Panther. As it turned out, 38% of the German tanks in Normandy were Panthers, whose frontal armor could not be penetrated by the 75mm guns of the U.S. M4 Sherman. The British were more astute in their recognition of the danger posed by the increasing armor strength of German tanks. Work on a more powerful anti-tank gun had started in 1941, and the tanks to use it in 1942. When these programs were delayed, a stopgap solution was found. The 17 PDR could through modifications be fitted to a Sherman, and orders for this Sherman Firefly were placed in 1943. By the time of the Normandy invasion 340 Sherman Fireflies were available to the Commonwealth armored divisions. The British lobbied for American production lines to be modified to produce Fireflies, just as they had been modified to manufacture the American P-51 fighter with the British Merlin engine, but these suggestions were ignored by the U.S. Army, in part due to the poor performance of British tank designs in North Africa. There were also 200 interim Challenger tanks with a 17-pounder and other improved tank designs under development. British and Commonwealth tank units in Normandy were initially equipped at the rate of 1 Firefly in a troop with 3 Shermans or Cromwells. This ratio increased until, by the end of the war, half of the British Shermans were Fireflies. The Comet with a gun similar to the 17-pounder had also replaced the 75mm gun Sherman in some British units. The 17-pounder with APCBC shot was more or less equivalent in performance to the Panther's 75mm gun, but superior with APDS shot. At the time, U.S. armor doctrine was dominated by the head of Army Ground Forces, General Leslie McNair, an artilleryman by trade, who believed that tanks should concentrate on infantry support and exploitation roles, and avoid enemy tanks, leaving them to be dealt with by the tank destroyer force, which were a mix of towed anti-tank guns and lightly armored fighting vehicles with open-top turrets with 3-inch, 76mm or later, 90mm guns. This doctrine led to a lack of urgency in the U.S. Army to upgrade the armor and firepower of the M4 Sherman tank, which had previously done well against the most common German tanks, Panzer IIIs and Panzer IVs, in Africa and Italy. As with the Soviets, the German adoption of thicker armor and the 7.5 cm Kw-K40 in their standard armored fighting vehicles prompted the U.S. Army to develop the more powerful 76mm version of the M4 Sherman tank in April 1944. Development of a heavier tank, the M26 Pershing, was delayed mainly by McNair's insistence on battle need, an emphasis on producing only reliable, well-tested weapons, a reflection of America's 3,000-mile supply line to Europe. An AGF policy statement of November 1943 concluded the following. The recommendation of a limited proportion of tanks carrying a 90mm gun is not concurred in for the following reasons. The M4 tank has been hailed widely as the best tank of the battlefield today. There appears to be no fear on the part of our forces of the German Mark VI tank. There can be no basis for the T-26 tank other than the conception of a tank vs tank duel which is believed to be unsound and unnecessary. Both British and American battle experience has demonstrated that the anti-tank gun in suitable numbers is the master of the tank. There has been no indication that the 76mm anti-tank gun is inadequate against German Mark VI tank. U.S. awareness of the inadequacies of their tanks grew only slowly. All U.S. M4 Shermans that landed in Normandy in June 1944 had the 75mm gun. The 75mm M4 gun could not penetrate the Panther from the front at all, although it could penetrate various parts of the Panther from the side at ranges from 400 to 2,600 am. The 76mm gun could also not penetrate the front hull armor of the Panther, but could penetrate the Panther turret mantlet at very close range. In August 1944, the HVAP 76mm round was introduced to improve the performance of the 76mm M4 Shermans. With a tungsten core, this round could still not penetrate the Panther glacis plate, but could punch through the Panther mantlet at 800 to 1000 yard, instead of the usual 100 yards for the normal 76mm round. However, tungsten production shortages meant that this round was always in short supply, with only a few rounds available per tank, and some M4 Sherman units never received any. Whereas Sherman tanks used a high flash powder, making it easier for German tankers to spot them, German tanks used a low flash powder, making it harder for Allied crews to spot them. Shermans, even though they were around 15 tons lighter than Panthers, had worse cross-country mobility due to their narrower tracks. A U.S. corporal said, "I saw where some MKV tanks crossed a muddy field without sinking the tracks over 5 inches, where we and the M4 started across the same field the same day and bogged down." The 90mm M36 tank destroyer was introduced in September 1944. The 90mm round also proved to have difficulty penetrating the Panther's glacis plate, and it was not until an HVAP version of the round was developed that it could effectively penetrate it from combat range. It was very effective against the Panther's front turret and from the side, however. The high U.S. tank losses in the Battle of the Bulge against a force largely of Panther tanks brought about a clamor for better armor and firepower. At General Eisenhower's request, only 76mm gun-armed M4 Shermans were shipped to Europe for the remainder of the war. Small numbers of the M26 Pershing were also rushed into combat in late February 1945. A dramatic newsreel film was recorded by a U.S. Signal Corps cameraman of an M26 stalking and then blowing up a Panther in the city of Cologne, after the Panther had knocked out two M4 Shermans. Production of Panther tanks and other German tanks dropped off sharply after January 1945, and 8 of the Panther regiments still on the Western Front were transferred to the Eastern Front in February 1945. The result was that for the rest of the war during 1945, the greatest threats to the tanks of the Western Allies were no longer German tanks, but infantry anti-tank weapons such as the Panzerschreck and Panzerfaust, and infantry anti-tank guns such as the ubiquitous 7.5 cm Pak-40, and self-propelled anti-tank guns such as the Marder, Sd.G3, Sd.G4, and Jagdpanzer. A German Army status report dated March 15, 1945 showed 117 Panthers left in the entire Western Front, of which only 49 were operational. Further development, Panther II. The early impetus for upgrading the Panther came from the concern of Hitler and others that it lacked sufficient armor. Hitler had already insisted on an increase in its armor once, early in its design process in 1942. Discussions involving Hitler in January 1943 called further increased armor. Initially referred to as Panther II. This upgrade increased the thickness of the glacis plate to 100 mm, the side armor to 60 mm, and the top armor to 30 mm. Production of the Panther II was slated to begin in September 1943. In a meeting on February 10, 1943, further design changes were proposed, including changes to the steering gears and final drives. Another meeting on February 17, 1943 focused on sharing and standardizing parts between the Tiger II tank and the Panther II, such as the transmission, all-steel road wheels, and running gear. Additional meetings in February began to outline the various components, including a suggestion to use the 88 mm/71 KWK-43 gun, however it was ultimately decided to use the 75 mm KWK-42L/70. In March 1943, MAN indicated that the first prototype would be completed by August 1943. A number of engines were under consideration, among them the new Maybach Il-234 fuel-injected engine and the GT-101 gas turbine. Thus, plans to replace the original Panther design with the Panther II were already underway before the first Panther had even seen combat. But from May to June 1943, work on the Panther II ceased as the focus was shifted to expanding production of the original Panther tank. It is not clear if there was ever an official cancellation. This may have been because the Panther II upgrade pathway was originally started at Hitler's insistence. The direction that the design was headed would not have been consistent with Germany's need for a mass-produced tank, which was the goal of the Reich Ministry of Armament and War Production. One Panther II chassis was completed and eventually captured by the U.S. It is now on display at the Patton Museum in Fort Knox. An AUSF-G turret is mounted on this chassis. Panther AUSF. After the Panther II project died, a more limited upgrade of the Panther was planned, centered around a redesigned turret. The AUSF-F variant was slated for production in April 1945, but the war ended these plans. The earliest known redesign of the turret was dated November 7, 1943 and featured a narrow gun mantlet behind a 120 mm thick turret front plate. Another design drawing by Rheinmetall dated March 1, 1944 reduced the width of the turret front even further. This was the term Panther. Several experimental Schmalter 1/4 RME were built in 1944 with modified versions of the 75 mm KWK-42L/70, which were given the designation of KWK-44/1. A few were captured and shipped back to the US and Britain. One badly damaged vehicle is on display at the Bovington Tank Museum. It had been used as a post-war range target until its historical significance was recognized. The Schmalturm had a much narrower front face of 120 mm armor sloped at 20 degrees. Side turret armor was increased to 60 mm from 45 mm. Roof turret armor increased to 40 mm from 16 mm. And a bell-shaped gun mantlet similar to that of the Tiger II was used. This increased armor protection also had a slight weight saving due to the overall smaller size of the turret. The Panther AUSF-F would have had the Schmalturm, with its better ballistic protection, and an extended front hull roof which was slightly thicker. The AUSFF's Schmalturm was to have a built-in stereoscopic rangefinder and lower weight than the original turrets. A number of AUSFF hulls were built at Daimler-Benz and Jostal-Hattingen Steel Works. However, there is no evidence that any completed AUSFF saw service before the end of the war. Proposals to equip the Schmalturm with the 88mm KWK-43L/71 were made from January through March 1945. These would have likely equipped future German tanks, but none were built, as the war ended. E-50, the E-series of tanks are Euro E-25, E-50, E-75, E-100, was proposed to further streamline production with an even greater sharing of common parts and simplification of design. In this scheme, the Panther tank would have evolved into the E-50. A conical spring system was proposed to replace the complex and costly dual-torsion bar system. The Schmalturm would have been used, likely with a variant of the 88mm/71 gun. Derived vehicles. Jagged Panther, heavy tank destroyer with the 88mm/71, Panzer Panther, command tank with additional radio equipment, Panzer Panther, observation tank for artillery spotters. Dummy gun. Armed with only two MG-34, G Panther, armored recovery vehicle, Flak Panzerkampfwagen, anti-aircraft tank project, planned to be armed with twin Flak 43-37 OMA guns in an armored turret, post-war and foreign use. Although a technologically sophisticated vehicle for its time, the Panther's design had a very limited influence on post-war tank development. The French post-war AMX-50 tank prototype was directly and significantly influenced by it, but never entered series production. The French did produce a modified version of the Panther's 75mm KWK-42L/70 gun, as the 75mm DEFA and CN-75-50 gun. This equipped the first iteration of the AMX-13 light tank as well as the Panzer DBR armored car, and was also used by the Israeli M50 Super Sherman. In his comparison of the Panther with the Soviet T-34-76, military historian Steve Zaliger argued that it could be regarded as an early precursor to the modern main battle tank. A class of tanks that did not appear until some 20 years after the war. The Panther itself also saw some limited use outside the German military, both before and after 1945. During the war, the Red Army employed a number of captured Panthers. These were repainted with prominent Soviet emblems and tactical markings to avoid friendly fire incidents. The Red Army still used a few Panthers as late as spring 1945. Unlike captured Panzer IVs and Stugs, the Soviets generally only used Panthers and Tigers that had been captured intact and used them until they broke down, as they were too complex and difficult to transport for repair. Panzer IVs and Stugs, on the other hand, were so numerous in terms of spare parts and easy to repair that they could be used over a much longer period in combat conditions. During March-April 1945, Bulgaria received 15 Panthers of various makes from captured and overhauled Soviet stocks. They only saw limited service use. They were dug down, with automotive components removed, as pillboxes along the Bulgarian-Turkish border as early as the late 1940s. The final fate of these pillbox Panthers is unknown, but sources indicate that they were replaced and scrapped in the 1950s. In May 1946, Romania received 13 Panther tanks from the USSR. They were initially used by the 1st Armored Brigade, but in 1947 the equipment was ceded to the Soviet-organized Tudor Vladimir Rescue Division, which was transformed from a volunteer infantry division into an armored one. The Panther tank was officially known as T5 in the Army inventory. These tanks were in poor shape and remained in service until about 1950, by which time the Romanian Army had received T-34-85 tanks. All of the tanks were scrapped by 1954. The tanks were different models, AUSF-A, AUSF-D and AUSF-G. They were shown to the public in 1948, during the 1st of May parade in Bucharest, painted with Romanian markings. Until 1950, the T-5 was the heaviest tank available to the Romanian Army. One captured vehicle also saw service with the British Coldstream Guards for some time. Japan reportedly bought a single Panther AUSF-D for reverse engineering purposes in 1943. However, the tank apparently never made it to Japan. The Panther's sloped armor and turret design nevertheless influenced the design of Japan's last wartime tank prototypes, the medium Type 4 Chi-2 and heavy Type 5 Chi-Ri. After the war, France was able to recover enough operable vehicles and components to equip the French Army's 503 Ra copyright Regiment de Chars de Combat with a force of 50 Panthers. These remained in service until about 1950, by which time they had all been replaced by French-built ARL-44 heavy tanks. In 1946, Sweden sent a delegation to France to examine surviving specimens of German military vehicles. During their visit, the delegates found a few surviving Panthers and had one shipped to Sweden for further testing and evaluation. Testing continued until 1961. The tank is currently on display in the Deutsches Panzermuseum in Munster. The last production Panthers were produced at the factory by German staff just after the end of World War II under the supervision of the Royal Electrical and Mechanical Engineers using available components. A complete Panther and a complete jagged Panther produced this way were shipped back to Britain for post-war trials. Both vehicles are now at the Bovington Tank Museum, Dorset, with brass plates on them, explaining their history. 1947 French assessment. The French Army used captured Panther tanks from 1944 to 1947, making it the longest operator of the vehicles. They were used by the 501st and 503rd Tank Regiments. In 1947 the French War Ministry wrote an evaluation of them entitled Le Panther 1947. While noting that the tank was a great gun platform with extraordinary range, it was mechanically fragile, which severely limited its use. The overall assessment was that it was not a strategic tank because of its high rate of breakdown. Some of the highlights were that the gun sight was extraordinarily clear out to 3000 am, the wide vehicle provided a stable firing platform, and that the 7.5 cm cannon could hit targets consistently out to 2000 am. The negatives outweighed of the positives, however. One was that the gunner was limited only to his gun sight for vision, making him operationally blind. That meant that when the commander found a target it took 20–30 seconds for the gunner to line up his sights and fire. This was far longer than contemporary tanks such as the Sherman. One major factor in the survivability of a tank was getting off the first shot. For the Panther it was at a decided disadvantage at that. The major drawback of the vehicle, however, was its mechanical unreliability. The Panther was built to last for 5,000 km, but many of the parts did not survive that long. The tracks and running gear had a life of 2,000–3,000 km. The engine on average only lasted 1,000 km. Most importantly, the final drive only had a life of 150 km. Half of the Panthers found in Normandy were abandoned due to their final drives breaking down. For that reason the Germans tried to move the Panthers by train as much as possible, even for small journeys of 25 km. The French paper put into question the claim that the Panther tank was one of the best of World War II. It was well suited for the defensive battles that the Germans found themselves in from 1944–45, where its thick frontal armor and long-range gun could be put to good use. However, it was not well suited for close-range engagements because the gunner took so long in acquiring his target after the commander identified it. More importantly, its mechanical drawbacks meant that it could not carry out any sustained offensive operations like the German Panzer IV, the Russian T-34, the American Sherman or the British Cromwell. Gallery. Surviving vehicles, in working order. Military Vehicle Technology Foundation, USA. AUSF. A. Musa Copyright E des Blinder Copyright S, France. AUSF. A. Deutsches Panzermuseum, Munster, Germany. AUSF. A command tank, Wahltechnische Studiensammlung, Koblenz, Germany. AUSF. G. Completed after the war in the Panther factory under supervision by UK REME engineers, used for tests, Friedrich Christian Flick Private Collection, Germany. AUSF. G completed after the war in the Panther factory under supervision by UK Army engineers, used for tests, Kubinka Tank Museum, Russia. AUSF-G, not running, more or less complete. Wilhelmina Park, Breda, the Netherlands. The only known complete surviving AUSF. D. This tank was donated by the Polish 1st Armoured Division after liberating Breda. It was restored in 2004 Euro 2005 for static display by Kevin Wheatcroft in exchange for automotive components. Panzermuseum Thun, Switzerland. Advertised as an AUSF. DG hybrid, with a D hull and G turret. There are many questions surrounding this vehicle. The turret has a replacement sheet metal mantlet, vaguely resembling a late AUSF. G mantlet, with no ports for gunner's sight or coaxial MG. The pistol port on the turret rear indicates an AUSF. An or early AUSF-G. The hull with the letterbox MG slot indicates an AUSF. D or early AUSF. A. The turret and hull numbers could help identify the correct model designation for the hybrid, but neither of the numbers have been made public. The Wheatcroft Collection, Private Collector, UK. The collection has 3 Panthers, one being restored. Early AUSF. A. Canadian War Museum. In January 2008 a partially restored Panther AUSF. A was put on display. It had been donated to the museum from CFB Borden, which acquired it following VE celebrations in May 1945. It had spent 2 years in restoration prior to being put on public display. Rex and Rod Cadman Collection, UK. AUSF. A. Sinchim Auto and Technique Museum, Sinchim, Germany. AUSF. A. Musa Copyright E des Blinder Copyright S, Sourma, France. AUSF. A. AUSF. G. Moulin-le-Grand, France. AUSF. A. Bovington Tank Museum, UK. AUSF. G completed after the war in the Panther factory under supervision by UK Army engineers, used for tests. Houffalize in the Ardennes region of Belgium. A Panther AUSF. G can be found in the village. It fell into the river during the Battle of the Bulge and was later retrieved as a memorial. The National War and Resistance Museum, Overloon, in the Netherlands, has an AUSF. G that was knocked out by a PIAT projectile during the Battle of Overloon. U.S. Army's National Armor and Cavalry Museum, Fort Benning, Georgia, USA, collection consists of the following 4 Panthers, PZVAUSF. A. PZVAUSF. G. PZVAUSF. G with chin. And Panther II. Several of these were part of the ordnance collection that was at Aberdeen, MD, Rex. Sinchim Auto and Technique Museum, Sinchim, Germany. AUSF. A. Overlord Museum, Colleville-sur-Mer, France. AUSF. A will be cosmetically restored and displayed in the new museum in a diorama representing a field repair unit of the Wehrmacht, along with a Strabo Fries gantry. Kevin Wheatcroft, Private Collector, UK. 2 AUSF. A. 1 to be restored and 1 to be restored to AUSF. D. Grand Menil, Belgium. AUSF. G. Cells, Huyet, Belgium. AUSF. G. Detailed specifications, armor. All angles from horizontal. Hull front, lower, 60 mm at 35 a degree. Upper, 80 mm at 35 a degree, hull side, lower, 40 mm at 90 a degree. Upper, 40 mm at 50 a degree. AUSF. G. 50 mm at 60 a degree, hull rear, 40 mm at 60 a degree, turret front, 80 mm at 78 a degree. AUSF. A. 110 mm at 78 a degree. AUSF. G. 100 mm at 80 a degree, turret side, 45 mm at 65 a degree, turret rear, 45 mm at 65 a degree. Turret, top, 16 mm at 5 a degree. AUSF. G, 30 mm at 5 a degree, gun mantlet, 100 unrounded, see also. Notes. References. External links, Littlefield Panther, AFV database, Panther, and Panther Duetaktung Panzer. Panther's Survivors, a PDF file presenting the Panther tanks, 1943 U.S. intelligence report on Panther tank, a photo slideshow of the Panther tank, Panther V Bell, a manual for the Panther tank, Panther II tank photos at 5-star general site, tank duel at the Cologne Cathedral Pershing vs. Panther.